Hello, everyone. This is your trainer, Akash Sharma. I hope you guys are doing good. We will be starting the session in a few minutes once everyone joins in. In the meanwhile, if anybody have any question or any query, please put them up in the chat box. Thank you.
ఏదో కట్టుకొని 100 starting there. పెట్టుకోండి ఇది అక్కడ ఇచ్చే పైన. హలో సార్, అలాగే అసలు ఊరికే వచ్చాడు వాడు. అదే అలాగే సార్. అంటే క్యాంటీన్ కి లైసెన్స్ లాగా ఫుడ్ FSSI అని ఒకటి ఉంది, అది తెచ్చుకోవాలంట. దానికి అవి చెప్పాడు ఏం కావాలని. అంతే సార్. ఓకే ఓకే అంతే సార్. అది అమ్మని చెప్పి బేసిక్ దాంట్లో ఇచ్చాను. బాగా వేరే పరీక్షలు రాయడం సార్ అడుగు. టైం టేబుల్ తీసుకో. టైం టేబుల్ గ్రూప్ లో పెడుతున్నారుగా. అలాగే ఆయన ఎంత 21 ఒక 6 27 ఒక 7 3 ప్లాన్ చేయాలి. ప్లాన్ 250 కూడా ఉండదు. 280 ఫైల్. రెండో ఫైల్ వచ్చి తక్కువ ఫైల్ ఎంత కదా. ఆ పెద్ద ఫైల్ ఒకటి, చిన్న ఫైల్, 2 రకాల ఫైల్ ఆయన తెచ్చు. వీళ్ళకి బుక్స్ ఏదో ఇవ్వాలి. 300 పుస్తకాలు ఉన్నాయి. కాస్ట్ ఎక్కువ. పెన్ డ్రైవ్ అయినాయి 250 పెన్ డ్రైవ్. అందరికి 16 GB పెన్ డ్రైవ్. ఫస్ట్ ఇయర్ పిల్లలు ఎక్కువ మంది ఉంటారు కాబట్టి 8 పెన్ డ్రైవ్ తీసి 16 GB పెన్ డ్రైవ్. సుభాష్ చెప్పు, లేదంటే మాతాజీ ఉంటాడు శివుడు గుడి ఎదురు సొంతం. 200 ఇవ్వమను. 16 GB.
సరే సుపదం ఆ ఎంట్రీ పేరు చిన్నపిల్లలు తిరుపతిలో. అవును, పేరు గుర్తు రాలేదన్నారు ఇందాక సార్. సుపదం సార్ ఎంట్రీ. మేము దానిలో నుంచి వెళ్తాము. సుపదం. అవును.
Recording in progress. Have those visualizations and the BI applications UI which can make the user ex, uh, ex-
Hey everyone, I'm your trainer back again. So today we're going to have another interesting session on wireless analysis. So that's what we'll continue today. Today is day 14th of our training program. Let me just share my screen quickly. So majorly today we'll discuss about two tools whose names are Wireshark and TCPdump. Both are kind of an alternate to each other. When you talk about Wireshark, basically it's used for GUI platforms. TCPdump is used for CLI platforms. You already know by now GUI is graphical user interface. Whereas when you talk about TCPdump, it's CLI, that means command line interface. So by now you must have made an understanding that Wireshark can be used on Linux, Mac, Windows. TCPdump is a tool for Linux in specific. Correct? That's what it is about. Now, what are they used for? They are used for wireless analysis, packet analysis. You can analyze various packets with both of these tools, and I'm going to show you how. Let's talk about the easier one, Wireshark. Okay, let's look into the process, how we can install it. Go on Google and look for Wireshark download. When you open the page, download Wireshark, this is the kind of interface you'll get. And you can see actually you can download for both operating systems, for Windows or for Mac, whatever you have. I'm going to install it for my Windows 64 because that's the one I am using. This one. It will download the exe for me, obviously, because it's in Windows. I have it downloaded. So we'll start with the installation process, obviously, first. Click next. Click noted. It's just a license agreement. Just click on all the positive options. Click next, next, and yeah, next. If it asks you to, if it shows you an option to install some packets like USB PCAP, you should be installing it. So put a check mark over here. Just make a check mark like I did, and then click next. Now let's wait for it to install. Now it is showing me a box here to install the USB PCAP driver. So I'll accept over here, accept the license and agreement, and then click next, accept, and next, install. Let's wait for it. It's done. So close it. Now let's just wait for it to complete, I guess. Once it is done, click next. It will show you an option to reboot, but I mean, you should be rebooting it, but I'm not going to do that. It's okay. I will choose the option of I want to manually reboot later. A reboot will basically implement all the configuration that we just made with Wireshark. But if I search for Wireshark now on my system, I must be able to see it over here as an application, Wireshark. Let's open this and see what do we have here. Okay, so this is the kind of interface you will get for Wireshark. If you will analyze a little bit, these all details mentioned here are just your network interfaces. These are all the network adapters connected to your system. So the one that I generally use is either Wi-Fi or Ethernet. I'm sorry, I cannot zoom in much into this because it's a software. So if it's having this like smaller font, so I really can't do much about it, but let's see what we can do with it. So to analyze certain networks, analyze certain adapters, we'll be basically be able to check what kind of traffic we are having on these adapters in specific. Like, for example, you can see some traffic going on my Wi-Fi, on my Ethernet 4 and Ethernet 2, right? And so these are the internet adapters that I have in usage over here. This is my primary Ethernet internet connection. My Ethernet 4 and 2 are for different switches that I have here. By default, we all must be connecting with Wi-Fi. So let's just analyze for Wi-Fi. When you make a double click on this analysis part, you can see this structure over here. This is some data input and output showing here. This defines that there is some activity in this adapter in specific. Because for all these adapters, it's empty, it's blank. That means there's no activity in there. So when I make a double click on this activity, I will be taken down to another interface altogether, which shows something like this. I will make it full screen for you guys. So you can see this is how it looks like. So on the top section over here in section 1, and here is section 2. In section 1, you will see the packet transaction. Like whatever packets are incoming and outgoing. In section number 2, you will see packet details. On the top over here, you have the control bar. Here you can stop the packet analysis, you can restart it, you can save it, right? That's what you can do over here. It's a control bar to stop, start, and like reinitialize whatever you want to do with it. Then we also have here this filter bar where you can put filters in order to segregate the packet analysis that you have just captured. Now you can see these packets are being captured in real time, because you can see as of now, there are 24,000 packets, 25,000 now. 25,000 packets have been already captured. These can be incoming packets, can be outgoing packets, both, right? So far, these many packets have already been traveled in my network. Now, if I want to stop it, I'll click on the red icon on the top. It will just stop right away. So in total, before I stopped it, I've already captured almost 29,500 packets. Exactly, actually, 29,500 packets that I've already captured. So if I go on the very top, here I can see packet number 1, right? Every single entry in this section is actually called a frame. Every single entry is called a frame. So it's frame number 7, frame number 8, frame 9, 10, 11, 12, 13, 14, 15. They are called frames, okay? In this frame, what do we have here? We have first the serial number to show like what is the serial of, you know, the frame captured. Then it's a time that shows how long, at what time it got captured, like how long did it take to receive or deliver. And then there's a source, like where the packet was generated. Like suppose it generated on A is the source, and it got delivered on B. So B is a destination. As you can see, destination IP is also given. So if A have an IP X and B have an IP Y, so X is the source that is mentioned here, and Y is the destination that's mentioned over here. That's how it is. Okay. Then they have the protocol. What was the protocol used to deliver the packets? As you know, like every packet is delivered by a certain kind of protocol. We have TCP and UDP protocol majorly here, right? We have TLS as well, which was transport layer security. I have told about this as well. In the basics of networking, we've already learned all this. In the end, we have the length of the packet, like how much, what's the size of these packets, in bytes. Like, for example, this packet is 1120 bytes. Then in the very end, we have what kind of data this packet is holding, so what information this packet is carrying. So that's what is shown here in the end section, in the info section. Information is what the information the packet is carrying. Now, Wireshark will capture all the kind of traffics. Would that be TCP, could be UDP. Oh, yeah. So could also be HTTP, could also be FTP, could be SSH. Any protocol that runs in the network, Wireshark can capture it. Okay. It can show you the packet capture for the same. It can capture those frames, for example. Okay, if I show you a sample over here, there are a lot of UDP packets here. Let me start the scan again, continue without saving. Let me visit any website randomly, like okay, I'm going to stop the packet capture now because I just completed my transaction, and I'll show you now what can we do in Wireshark. Now, among these 7,000, almost 7,000, or I think like 6,000 packets here, I have that one packet which is having my information. I just went on browser on my another screen and I just browsed something that you guys don't know about, but we will see how we can analyze in this Wireshark, how we can check that out, right? That's what we will see. Okay. So what did I do? Let's understand that. I went on a website, right? First of all, in my browser, I opened a website here. Let's say xyz.com. Okay. And once the website was loaded completely, I went on the search bar and searched for a keyword. This keyword K is actually this. This is what I searched for. Okay. This was my keyword. Now, because all this transaction happened from my browser, which is on A, and it went to the server, which is B, right? So my origin, the source is A, destination is B, which is the server. So the source IP should be here, destination IP should be here. So it must be very clear with me that source IP is going to be my IP because it's generated from my system. So quickly, if we can check our IP address, we will see it here. This is my IP over here, 1.4. You can see, right? So 1.4 is my IP. So it must have generated from my side. How we can do search, how we can search it, because here are only 6,000 packets, right? Only 6K packets. There will be scenarios where you'll be dealing with maybe 600,000 packets. See? So how would you really be able to filter the traffic efficiently? So on the top over here, you will see there is a bar that says apply a display filter, right? Apply a display filter. So these display filters can actually segregate the network traffic and show you the specific thing that you're looking for. Let's say that I want to look for my specific keyword that I used. So it is going to be in one of my frames. So I'll type frame, I'll type contains, and then I'll type the keyword that I want to look for, which was this. So this is going to be my filter that I'm going to put. You can see here, I'm going to make it show you bigger. So this is my keyword. This is the filter I'm going to put. And once I'm done typing it, I'll just press enter. And as soon as I do it, out of all these 6,000 packets, it showed me those two packets, those two frames, which were having that keyword in specific. And you can see very clearly it's showing here. In the info, this is frame number 5595 and 5628. Two different frames out of those 6,800 packets, 6,800 frames. This generated from my side and went to the website, and this is when the website responded me. So I have both kind of packets captured. The packet that generated from my end was using HTTP protocol, and the packet that came in from the server was a TCP protocol. And you can see in the info, I can see the query T3RABYT3 terabyte. I can see it there. If I click on that particular frame 5595, you will see at the bottom I have some new information over here. So let's look into it. So in the first line, it's just showing me the frame detail, like the frame number and how many packets, how many bytes were captured, basically the length of it, what interface was being used, right? General stuff like Internet Protocol version number 4, source and the destination, what were the ports being used, all that information, basic stuff. But at the end, I have here HTTP, Hypertext Transfer Protocol. So let's take a look. What do we have inside that? Because it's a drop-down menu. So when I click on that, it shows me what it contains. Right. So here you can see it's showing me the host was eltoromutual.com. That was the website I visited. As of now, we didn't knew that. Now you know it. This was a user agent. I was using a Mozilla browser. Right. More information is referrer. This is a cookie. You can see the session ID as well. Remember, we saw all this thing yesterday itself. In Burp Suite, we have also seen this, right? So this means this not yesterday actually. We saw this a few days back. We saw this in Burp Suite. Burp Suite was also able to capture these kind of packets, and we were able to see what kind of information they were holding. And on the very top, just like Burp Suite, we have the information that was carrying. So there was a parameter query which was having my keyword T3RABYT3. For those who don't know, it's basically spelled as terabyte. It's like kind of my alias name. So yeah, so that's terabyte. Now, this is the parameter, and I almost got not actually almost, I got literally all the information that was going from my system to the target server. right? So I can capture those packets. Similarly, whatever was being delivered, I can also see that this was a TCP protocol. So there's not going to be much information in there, but let's just have a look. You can see that these are just like basic information of the number of packets and the sequence and everything that delivered. So raw packet details, which is not readable for us. It's just for the sake of the PC to understand. As of now, you don't have the experience to, bifurcate the meaning of what's being captured in TCP packet. But we can understand HTTP because like this is what we are working with. This is what we are working with on our browser. So we can easily see that. So this was one of the filters that says frame contains. This filter will basically bring out any keyword that is captured in any of the frames randomly. There are many other keywords that I would like to show you, for example, like if you want okay, I removed all the filter and all the packets are back here. You can see all the frames are back. Total 6,000 frames are here now. Now, my point is, if I want to scan some more frames, I want to filter out the frames which are having the source IP as 192.168.1.4. If I want the source IP to be 681.4, and I want all the packets, all the frames to be shown only with this source. I don't want other sources. I don't want any other frame with any other source. I only want frames which are having the source 192.168.1.4, right? So I can also put a filter for that. The filter would look something like this. Have a look. I'll type ip.src equal to IP address. So whatever be my IP address, I'll put it in there. Let's say I want this one. So I'll make it like this. So when I do this, take a look what happens. As of now, we have random sources as well. We have this as a source, another IPs. But now when I put my filter and I press enter, you see all the sources are this IP address. So this way I can analyze what packet were being sent from this IP address to any target, right? Similarly, I can also do for the destination that I only want to see the frames for this type of a destination. I want to see, like, let's say if this is my IP, 192.168.1.4, and I want to see how many packets were delivered to me. I don't care where they came from, but I only want that to see that how many packets delivered to me. So now if I do this, you will see the destination port will be having all my IP address. That's it. You see, the generation, the source was different all the time, but the destination was same in now after this filter, right? So that's how it can sort it out. I can also do it based on the TCP port as well. Let's say if somebody's using port number 21, right? Which is used for FTP, you know this, right? So I can do a filter like TCP dot SRC port and the port number, let's say it is 21. So if I want to search for this, there's no packet that generated from port number 21, which is okay. But if I look for port number 80, I can see all the packets now that generated from port number 80. The source that it generated from is port number 80. And if something is going to port number 80, that means the destination, then I'll do it TCP.DST port. Right? Simple stuff. I can also search based on the protocol. I just need to type the protocol and that will be all. Let's say I want to look for HTTP. So I just type HTTP in the search bar and I press enter. I can get all the frames for the HTTP traffic. You can see here, all of them are HTTP based. If I want for, let's say, TLS, I'll just simply type TLS and press enter. It'll show me all the TLS traffic. If I want to look for FTP, there is no traffic for FTP, right? So some of the basics can be covered up with this. If you want to look for ICMP protocol, there are 4 ICMP packets. If you see in live time, like right now, I am filtering only for ICMP packets. And if I do the ping or right now on one of my other IP address, you will see it happening in the live process 1.4, 1.14. Okay. So basically my device, which is 1.4, it is going to ping on 1.14, right? It's going to make a ping and you will see the packets being captured and what kind of protocol they are using. You can see the ICMP packets are being captured simultaneously as soon as the packet is leaving from my side, right? So there's a request going on, then there is a response coming back from 1.14 as well, right? So this request and response is being captured in Wireshark in the live time as soon as it was happening. So that is the great thing about Wireshark. It can do the live traffic analysis. This was for ICMP. If I go for HTTP, I can also do that. Let me open my Firefox here and let me show you something. If I go on, let's say, altoromutual.com, see the packet started to capture over here. If I search testing, I think I'm using some sort of proxy here. Don't mind it. Let me try again. Yeah, on Firefox there was proxy, that's why it was not showing, but it's okay. Now we have it. So you can see as soon as I made a search for testing, I was able to capture the packet here, which was having the query as testing, right? So Wireshark can be basically used for these kind of purposes where we have to scan the network and see what kind of, protocols are being used. If I want to filter based on the length as well, I can also do it. The filters for this will be, I'll share a document in my notes section on the drive where I will be sharing a complete Wireshark blueprint, basically. It will be like a complete guide on how to use these filters. You guys can also refer that. I'm just using a few of them because there's hundreds of filters, which definitely I cannot teach in a single day, but I'm trying to show you as much as possible. So let's say I told you about these two things called a get and a post. Remember, when I was teaching you burp suit, I told you about these things, get and post. Get is when your browser is getting something, and posting is when your browser is sending some destination. So in get method, we receive. I don't know if I spelled it right. In post method, we send, or actually we deliver, right? That's what we do. So if I want to filter these frames as well, where I want to check what kind of method we use to send or receive, I'll show you how we can do that also. You can simply type here the HTTP request method. What was the kind of request you were making? Were you making a get or a post, right? So if I want to search only for the post request, I'll simply put equal to post. Let's copy this and try searching for it. There are these many post requests, but if I look for get request, let's see how many get. Okay, these many are get request. So that means these are packets that were being delivered to me via HTTP. And the other ones were the ones that I sent from my side. So these were some more filters. Also, you can actually search by the frame length. If you know that how much length the page is going to have or your subject is going to have. Let's say I have this length over here, 357, right? And I want all the frames with the same length. Then we have a filter for that, which goes by frame.length, length, GTH. And then you give the length over here. Like 357. If I search for it now, oh, actually it's frame.len, not length. I'm sorry. Frame.len, len is for length. So I don't have to like type it the whole thing, but frame.len works out. Yeah. This changed after a recent update, so it confused me. It's okay. So let's press enter now. You can see now all the frames are showing. These are having the same length as 357 bytes. All of these are having the same length. But now if I know that my target that I'm looking for or the kind of packets I'm searching for, they must have at least minimum. I mean, I know that they will be at least larger than 1,000 bytes, right? They could be 1100, they could be 1700, they could be 2500, right? I don't know. But they are at least larger than 1000. And I want to see all the frames that are larger than 1000. And I can make a filter something like this, frame.len greater than 1000. This is a simple mathematical function if you remember this. So I'll copy this and I type in here in the filter bar. You'll see now all the frames that are coming in, they are more than 1000 bytes, right? I can also do the same filter for 1500 if I know that that's the minimum length my frame must be having. There are no packets more than, okay, there are packets now, there are more than 1500. Yeah. If let's make it 2000 or maybe 2500. Let's try that. Do we have anything? Yes, we do have packet lengths which are more than 2500 as well. These are TLS packets and TCP packet. So this way I can also, configure based on the length of the packet. Now, if you want, like we have seen here, the source and destination, right? Where the packet generated from, where it came to, right? These are two different things. But what if there is some sort of conversation that I want to capture? Because when I look for 1.4, you will see there are so many frames in here. So many of them, right? And it is actually conversing with a lot of different IP addresses. The destinations are very, very, very different, right? There's so many of them. but I want the conversation for a specific target only. So what I can do is I can also make it this way. I know that this is going to be my source, right? But I want only that destination which I am interested in. So I can put it this way, double ampersand ip.src equal to 192.168.1.14. Now it will show me only those transactions that generated from 1.4 and delivered on 1.14. Only those transactions. So this segregate the conversation even better, because now I don't have to deal with all the traffic that is being shown in 1.4, but only the traffic which will be between these two IP addresses. So if there is any kind of transaction going on here, I will be able to see it. For example, if I look for oh, I'm sorry. I'm sorry. I have to do it IP DST. I did IP SRC on both. There cannot be two IP addresses, right? It's have to be DST. Okay, now it makes sense. Okay, now you can see all the packets that are showing up here are the conversation between these two addresses. The packet that generated from 1.4 and that delivered on 1.14. So whatever I sent to 1.14, I can see it over here. That'd be a TLS, a TCP packet, or HTTP packet. I can also put HTTP at the end. So it will only look for HTTP traffic and HTTP. Now let's wait for it to scan all the packets. Give it a second, it will show. Come on. Okay, let's maybe look for ICMP. Okay, we can see ICMP. I'm sure we will also be able to see HTTP traffic. It's just that it's taking time to load. Okay, so these were a few filters that we just saw with respect to Wireshark. Wireshark is simple to use because it's like graphical user interface and we can see everything. By the way, if I have captured like these many packets, like already 7,000 packets have been captured. There are total more than 8,000 frames now. If I stop it right here with the right icon on the top, I can save this as well for later on, So how I'll do that is simple. I'll click on the file option on the top and I'll click on save. I'll save it on my desktop, let's say with the name testing, right? The Wireshark files are saved with a certain extension called PCAP, which is short for packet captures or packet captured. PCAP, that is the extension for these packets, right? So I'll save it now. Okay, it's done. So let's close Wireshark for now. And on my desktop, you guys can see there is this pcap testing.pcap file. Testing.pcap over here. Right. This is the Wireshark file now. And how will I use it? It's very simple. I just when I make a double click on it, it will automatically open with Wireshark and show me all the packets, just like this, you see? There you go. I'm able to see all the packets that were captured earlier. So if I want to analyze them later on, I can do that. I can also send it to somebody like one of my friends. And if I want him to analyze these packets, I can also do the same. So this way, packet analysis becomes really, really easier with Wireshark. So far, if anybody have any question with respect to Wireshark, let me know. Before I show you any more demonstration, I would like to know if there's any question or any query that you'd like me to answer. Okay, so moving on to the another version, which was the alternate to Wireshark, the TCPdump. Actually, it works exactly like Wireshark, but it's totally different. I know this sounds really confusing, but it's okay. I'll clear your confusion. Let me open Kali Linux over here, our old friend. Right. Okay, give me a second. Okay, so first we'll start, of course, with the system update. You guys already know this command. I've shown you this a lot of time before. Okay, so we are done with the update part. Okay. Moving on, we will install the TCPdump sudo apd -get install TCPdump. There you go. Okay, we have TCPdump here. So the question is, how do we really use it? It's very simple. To install to use TCPdump, you use a sorting command. It goes by sudo TCPdump -i eth0. So when I do sudo TCPdump, it starts the two. Oh, I'm sorry. My bad. You can see it started the TCPdump altogether. But right now it will be scanning all my adapters, all the network adapters, right? So if I want to scan a specific adapter, I can mention it. For example, when I do ifconfig, I can see the number of adapters here. One of them is ET0, the other is LO. So if I want to scan my Ethernet connection that I have here, so I can do TCPdump -i ET0. -i is for the interface that I want to scan in specific. The specific adapter that I want to scan with can be given with -i. Now, when I start the scan, it doesn't show you like much graphical interface. Rather, it just shows you, this command line interface only. All the packets that are going through will be shown in here. The incoming and outgoing both. I know it's not that flashy. It's not that interesting. It looks boring, frankly. But trust me, it is pretty good one, because as I told you, in multiple conditions, you will not be even given a graphical user interface. You will be completely depending on the CLI or maybe a command prompt or shell. So we will be depending on TCPdump in that case. So if I want to scan, okay, this was the basic scan, by the way. Just a second. Let me open the notepad here. Sudo TCPdump -i ETS0. Scan and analyze ETH0 interface. Right, that's what this command will do. Talking about the other command, if I want to scan a specific port, the command would be sudo TCPdump port 80. I can make it this way. So if I put the same command here, sudo TCPdump -i ETH0 port 80. You can see at the bottom, that's the command. And when I scan this, let's see what do we get. As of now, I'm not really doing anything on port number 80, but if I start doing something, let's say I go on a browser and if some traffic started coming in from port number 80, I can check that. go on eltoromutual.com. Here you can see it started capturing the packets that went on port number 80. If you'll read the packet, it's very explanatory. Let's say, for example, this one. Here it shows that this is your for your Cali, it's just say simply Cali, right? And it is now showing that what was the port number it was going on. It was going on 65.61.137.177. Then there is HTTP in the end, which defines the port numbers, of course, 80, because HTTP uses 80. And then there is a flag. This is the ACK flag. That means this was an acknowledgement packet that was being sent. And then there are options here. There are some other details. At the end, there is a length, which is 0. That means it doesn't have any much size. I mean, it was almost 0. That means no size was there. But if you'll see on the top, there are some more packets that can be analyzed over here. Sent from my Cali, received on the target. Right. The sequence and number of the packet is here. This was an acknowledgement packet number 16,441. Right. Here is the length of the packet, 349 bytes. It was on HTTP, and this was a GET request that was generated. So this way we can analyze these packets. TCPdump is complex. Okay, I totally understand. This is why I showed you before Wireshark, because it's more easier to understand and more easier to use as well in comparison to TCPdump. But on the other hand, TCPdump have its own benefits, because it works on Linux, it works on CLI. So in case if you don't have Wireshark, you can work with TCPdump. For example, I'm going to stop the scan and I will start a scan where I want to look for a specific IP address, right? Not a port number, but a specific IP address. So I'll type ETH0 host 192.16. Oops. Host 192.168.1.4. Okay. When I press enter, I'll be able to see if there is any kind of like communication going on between them. If there is any communication going on. Also, for example, I showed you for one single port, like port number 80, if I want only for port number 80. And let's say I want a complete range of ports, I can also give that. Let's say I want all the ports between 20 to 80, right? If I want all the ports between this range, I can also provide that. So it will scan all the ports between this range. Oh, I have to type port range like this. And let's press enter. Now it will scan all the packets that are being captured between this port range in specific. Yeah, I'm sorry, guys. I got disconnected. Don't mind that. There was some network fluctuation, I guess. Okay, so let's continue where we left. So I was telling about the drive, right? The Google Drive that I created for you. Okay. In the study material, we have the thing called Wi-Fi hacking with Kali. There are some courses over here, like the basic and advanced level, techniques that you can use to test Kali Linux, test your network or Wi-Fi with Kali Linux. There are so many different attacks that obviously I cannot cover in a single day, or for that, even in 15 days. Okay. These are extensive training and things, and I really can't just explain them in a single day or in this short period of time. But I'm trying to explain how the tools can be used. Okay, I'm trying to explain them. I'm not teaching you the offensive tools because we have done that yesterday once, and I think that'll be more than enough for you guys, right? So yeah, that is all actually. I will be uploading some more content in there, which with respect to all the topics that I have taught and some more additional stuff. For those who do not have the drive, I will be sharing the drive link one more time in the chat box. I humbly request everyone to save it. There you go. I've shared the drive link with you guys, and the team will share with the YouTube people as well. You guys can access the drive. It's free for use for everyone. It is everything is downloadable if you want to save it offline, if you want to reshare. Yeah, so yeah. Okay, so Santesh have shared me a screenshot and asking what this who has means over here. So let me explain. It's very simple, frankly. So this is a query. Okay, we call this probe or probe packet. This is going for a query to confirm who do have this particular IP address. So basically, this is sent by ARP, as you can see here. It's sent by the ARP to confirm that who is having this IP address. And this is a kind of a broadcast packet. It's broadcasted to all the devices, and whomsoever is having the IP address will respond to the sender, okay, which is 2.15. So 2.15 initiated a broadcast to confirm like who is having this IP address. This is one attempt of confirming a MAC address. Somebody is actually, basically what's happening is 1.15 here is trying to make a network scan and confirming based on the MAC address who have the IP address. He already might have the MAC addresses in the network, and based on that, it is finding the IP address. And it's possible because of ARP protocol. So that's what's happening here. Okay. So yeah, we are actually done with today's session as well, frankly. I know it wasn't much, but I think it was pretty good enough for you to do the research based on Wireshark on packet analysis. You can also see like how more you can modify Wireshark. I'll upload some Wireshark specific videos. I have some training modules on that. I will be showing them. And now, if anybody ever have any questions or any kind of queries they want me to answer, the chat box is always open for you guys. Any question will be welcome if there is from today's session or from any session from the past. The team has also been sharing the attendance link. You guys kindly fill that too. It's important. You guys made it till here. And one more major update before you guys leave anytime. We are going to have a session tomorrow as well, same timing, because we missed the session the last week, I guess. And on Friday, we missed it. So we're going to have a session tomorrow, 3 to 5, the last and the final session on cryptography. We're going to have that. And the attendance link will be shared too. There will be some additional notes I'll share probably, right? So do attend that as well. Tomorrow is no holiday for you. You guys will be coming in. Now I'm answering the questions on the chat box. Well, I have answered most of the questions in the chat box, I think. And yeah, we can conclude today's session for today. We will see you tomorrow, same time. And I'm delivering this back to the ExcelR team. Thank you so much, everyone. I wish you good luck, and I'll see you tomorrow, same time. Do not miss tomorrow's session, okay? It's going to be on cryptography. It's because there will be some interesting tools. So do attend it. Thank you.
Thank you, Akash.
Thanks.
Guys, is there any question for me? Please let me know in the chat box. And one more thing, already Akash told that tomorrow we have a last session in cyber security. So please attend the session tomorrow. Don't miss it. I think there is no more questions for me. So I'm sharing again that feedback link. Please make sure our attendance. Okay, we'll wind up the session for today. We'll meet you on the tomorrow same time. Thank you so much for joining the session. Okay, then we'll meet you on the tomorrow. We'll wind up the session for today. Thank you so much. Bye.